The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone, and welcome to today's webinar, Enhancing Telecom Digital Twin Use Cases, Combining Engineering-Grade 3D Modeling within the HoloLens. Thank you so much for joining today. I'm going to go over just a quick housekeeping items. So let me just quickly, for some reason, I have the menu here on top of my presentation. There we go. So you most probably have joined using the internet, but just be aware that you can also join using the phone if your internet drops for any reason. So if you click on the phone call, you will see your dialing information. Always useful to know that there is an orange arrow, so that's the actually the one that I was looking for to expand and collapse the menu. Then I've made available 2 handouts, which are actually really, really interesting, and I strongly recommend you to have a look at them. It's an infographic and a document created by Visual Intelligence regarding this millimeter grade accuracy, inspection grade versus engineering grade, and they are actually really, really interesting. So please have a look at them. So if you go and click on them, they will download automatically on your computer. And then please use the chat box, so the question box, to drop us any comments or questions or thoughts at any time during the webinar. We love these live events because you are part of it, so you have the chance to ask questions and share your feedback and thoughts. That's the reason why we are here. So at any stage, I'll be just monitoring and see if anyone wants to drop a question, and then we'll try to address them real time. A few other things, again, use the chat. We love your questions and your comments, so please keep them coming. We will send you the recording in the next few days, so no need for you to take notes. Just sit back, relax, and enjoy the webinar, as they say. Tell us how we did it in the survey. So as you leave the GoToWebinar, there will be a survey prompted, and that's the only way we have to improve these events for you guys. So if you take a couple of minutes for those 5 questions, I think that would be great. And finally, stay tuned for our next webinar. You can follow all of us on LinkedIn, so you will hear about the next events coming up. And I think with that, we can start with the presentations. Hi, everyone, again. My name is Alicia. I work as a sales campaign manager at Virtuosity, a Bentley systems company. For those who are not familiar with Virtuosity yet, we are the new e-commerce platform from Bentley Systems. So we provide Bentley licenses through a yearly subscription, Jesus, a yearly subscription with added services like dedicated training and support. So I recommend you guys go onto virtuosity.com and hear more about our subscriptions. And we are having some technical issues. Well, Greg is actually having some technical issues, so he hasn't been able to join yet. So I'm gonna try to look after that, while Spencer, if you want to introduce yourself, and I'll see if I can grab Greg back into the call.
Yeah, lovely. Thank you. Alicia, that's a great introduction, and welcome to everybody joining the webinar. I know you're probably from different parts around the world, so good morning, good afternoon, good evening, whichever location you're in. My name is Spencer Crawford-White. I am a partner in Visual Intelligence, but also representing myself as a subject matter expert from an engineering position. For over 25 years, I've worked in the telecommunications industry, originally as a tower climber and a structural engineer, and then progressing through the business roles of project management through sort of business direction. And for the last 10 years, I've been literally traveling the world to over 80 countries, looking at tower companies, the evolution of tower companies, working with mobile operators and OEMs, looking at tower infrastructure efficiency and management. And for the last 3 or 4 years, really been focused on new technology and drone application. And so it's joining Visual Intelligence and seeing this millimeter grade data is very, very close to my heart as a structural engineer. It's the important part of what we do. And we're going to give you a demonstration later today. Greg's here, so we'll introduce Greg in a moment. and we'll do a proper introduction to visual intelligence in a moment. But again, just like to say thank you to everybody for joining. Hi, Greg, how are you?
Hi, Greg. Good to see you.
Oh, hey, yeah, I made it. Hi, how's it going?
This
You
is
did.
Just had some internet connection issues here, but I made it. Hello, everybody. Greg Demchak with Bentley Systems. I run an innovation lab within Bentley. We focus on all things digital twin. And specifically, we're looking at how does the digital twin interact with new types of hardware, human-computer interactions, such as the Microsoft HoloLens, which is a hands-free interactive system for working with 3D models and perspective projections. It's kind of taking the models out of the screen and into holographic form. So yeah, excited. And we're looking at all these different use cases, 3D models, photogrammetry models, cell phone towers, bridges, sort of everything is kind of on the table. And so we're going to be showing a cell phone tower example today, digital twin.
Thank you so much for that introduction and welcome. I'm delighted to see you.
Yeah.
To see you both, actually. So cool. Thanks for the introductions, guys. Before we get started with your presentation, Spencer, I want to quickly ask everyone, if you have been in one of my webinars before, I love to engage with you guys just to make you part of this. So I just want to quickly ask you, which of the following best describes your business or your industry? So if you go back to the GoToWebinar window, you will see poll on the screen. So if you quickly answer that, so we have an idea who is in the audience today, and we can, address you guys a bit better. So we have loads of engineering companies, a little bit of other. Okay, that's interesting. Maybe you can drop a comment and see which industry or how would you define your business. So let's me still moving there. Okay, I think we're going to close the poll now and sharing the results with you all so we know a little bit more of the audience. So look at that. Half of the audience is describe themselves as engineering companies. We have some general contractors, asset owners, very little network operators, and a big chunk of others. So guys, feel free to drop just a chat, a question and on the chat box, and let us know what industry or what your business does. That'll be great. Cool. So thank you so much for that. I'm gonna make Spencer presenter, and you should be good to go now.
Okay. I'm just gonna make sure we got my right screen here. I think it's gone blue. Yeah, let me just play the presentation. There we go. Hopefully you guys can see that popped up now. Is that visible?
Yes, that is visible now. Yep.
That's lovely. Yeah, look, interesting results, I suppose. Just to comment on the poll there, it's very difficult to sort of look at the whole spectrum of people that have been invited and pigeonhole them into 4 categories. So we totally appreciate the other. So yeah, any comments you have will be really appreciated. Before we get into this, obviously, we've just headlined this, and myself and Alicia and Greg, as a purpose, we're just going to run through basically 3 core sections as part of this. We'll give you a little bit of an insight to visual intelligence first for the next maybe 5-10 minutes, before then Greg and myself moving into the actual HoloLens product and giving you a live walkthrough of that, which is going to be really, really snazzy and interesting for you guys. Before then touching on some of the value propositions that we want to, or we believe that actually flow through from the amalgamation and consolidation of the engineering grade data and the use of a HoloLens type product. Our position in this is our position, and it may create debate, but this is all about sharing in this community before this is the future technology of what we're all going to potentially be inspecting and managing and engineering with in the future. So your feedback and your support, positive and negative, is really, really beneficial. It helps us develop, it helps us challenge our business, and it helps us refine the messages that we're putting out there to industry across the spectrum. Hence the poll being very important for understanding the classifications where you come from. So we'll leave that as a message there. As I say, positive and negative feedback and challenges to some of our statements is actually good feedback. You know, we want to work together with you guys. And if there's at any point any serious questions that you do have, which are going to take longer than a quick response, feel free to reach out through LinkedIn to any of us on here so we can give you further documentation, further justification. We did a LinkedIn live session last week where there were a lot of those types of questions, and we gave some technical understanding. So what we'll do is we'll just move on quickly into this presentation and just explain that visual intelligence background and history comes from the telecoms industry. We're not just drones. We have come from TowerCo leadership. As you can see here, the founder and CEO, chairman of Visual Intelligence, Mr. Ted Miller, industry recognized leader, was the chairman and CEO of Crown Castle, one of the first tower companies globally. Engineering expertise from myself and a number of others within the visual intelligence team, and a huge spectrum of technical experts who look at aerial inspection and have brought this technology through from sort of traditional inspection grade up to an engineering grade, where we've leveraged a 20-year-old technology, albeit, of photogrammatic combination for a patented sensor to get millimeter precise accuracy, and reduced and scaled down that product from what was traditionally on helicopters and planes into a drone, miniaturized it. Now technology is improving. Much more information is available on that if you visit the website or contact us directly of what we've done in that space. Looking forward, you know, our claims, the first millimeter accurate drone sensor for tower captures. We know there are other companies out there that capture millimeter in other sectors and other markets. We're not challenging that. We're looking at this as being, you know, 10 to 20 times more effective than what you can create from the ground with LiDAR methods, obviously with the height of tall structures and LiDAR's capability, and 50 to 100 times more accurate than those traditional off-the-shelf commercial drones that you can buy from, you know, the local supermarket or store in some cases. Again, more details of that are available in some of the documents that we've supplied within the webinar. But of course, if you have a specific question, more than happy to answer how those claims are substantiated.
And can I also add that we did a live event last week regarding the data acquisition and data processing. So I'll send you the link. I'll actually put the link on the follow-up email and on the chat box, so you guys have access to that. So it's a YouTube link. It's a 40 minutes or maybe 30 minutes video. And we had Jay, who is the photogrammetrist expert at Visual Intelligence, explaining the entire workflow. So I strongly recommend you guys to have a watch at that.
Yeah, definitely. And again, direct approach is perfectly acceptable as well. But in essence, what visual intelligence is we have patented this dual sensor. It is a revolutionary tool that we can get down to justifiable full 100% coverage, millimeter precision, engineering grade data from capturing a tower. We've got the platform then, the auto navigation flight process that enables the flight plans to be captured to high standard, to combine those images with the ability to then transfer that from anywhere in the world, a scalable solution in what we're saying, back to the processing house, where we do a lot of pre-processing to make sure the accuracy levels are there, and then work in partnership with, at the moment, Bentley with the analytics, where they apply their AI and their OpenTower IQ platform that some of you may know about, to get down to that sort of OpenTower design, a structural analysis piece, leveraging the visual intelligence millimeter grade data. So they're the three core buckets. There's loads more slides that we could bore you with if you want to be sent the full deck. But the ultimate aim is to understand what industry needs. So what does the tower industry need? They want inspection differentiators, the ability to see the structure from a different position. They want to identify their assets, their tower mounted equipment, their antennas, their dishes, their cables, and all the other items hanging on the tower or monopole or rooftop. The condition is very important, and comparative analysis from now to what it was before is what it is. And we've classified that grey here because that's pretty much available off the shelf in a lot of drone facilities. But the limitations are below the line, where we say you want to do a millimeter accurate CAD drawing. You want to be able to do a structural analysis. You want the ability to simulate new proposed equipment and work out what the capacities are, and you need to put that into a BIM functionality. And this is all the challenges we've been accepting, I suppose, over the last couple of years as tower owners and mobile network operators have really got up to speed of what this technology could do. And it's still a learning exercise for many of them. So knowing those challenges, and maybe a bit of a controversial slide, is we have looked at scanning towers with P4P, so Phantom 4 Pro data and our Max 3D visual intelligence sensor. And we've come up with this sort of matrix of business sectors versus specific activities within that, and basing our value proposition of where we can get confidence on the data set to achieve certain things. So if you just look in the grey areas, we're perfectly confident with, you know, a standard off-the-shelf drone can accommodate that type of request, and as it moves in with the blues in the engineering, we really need millimeter precision. So that, and again, the recording of this will give you more detail. Just again, this is the visual intelligence position. It's not quoting verbatim what is fact and accurate. It is what we have tested and what we have made available using our knowledge and our industry ability, comparing the two, because we fly P4Ps and we fly Mavics and we fly the M600 with the Max 3D. And so we have come up with this and our own data metrics, knowing the industry and what it is. So just to set the scene, later on there's going to be some value propositions which use these core headings to show you how that flows through. So it's sort of setting the scene, but happy to take comment and discussion on that at later points as well.
You've developed this graph thinking of the telecom industry, is it? But actually, if I read, you know, every of the cells, like it could be applicable to loads of other industries as well. Like I guess, you know, when we talk about assets and asset inspection.
100%. I suppose physical asset, portfolio asset, something with a need for engineering. It could be buildings, it could be, you know, flare stacks for the oil and gas industry. It could be, you know, whatever we need to turn this to, it's still applicable because millimeters matter. And that's our whole ethos. We've got a hashtag millimeters matter on the visual intelligence website. You know, what we're trying to justify here is it isn't always necessary. And this is where we're showing this graph, that you don't need to go to the ultimate end, but our ethos and our position is, if you can, why wouldn't you capture the best grade quality data that you can and at least sit on it for the future time that you do need it? And so capture now, pay later, deliver that model as you need it. At least it's land banked. And some of the value propositions show why that is valuable on repeat visits and reducing truck rolls, which the industry commonly phrases, even for standard off-the-shelf drones. So again, you're right though, it is applicable maybe to more than just the tower industry, but we are focused at the moment with this specialist area for the towers because we've got the HoloLens coming up shortly, just got a few more slides to go through, and it's focused around telecom structure. So that's why we wanted to bring that up. Just, you possibly have seen before some of the key outputs. This is, you know, the asset identification function where you can tag the antenna, you can see all the asset configurations and metrics that can come through from the platform. You've got the OpenTower IQ there. We've got the conditional responses of how we can achieve that. Again, standard products off the shelf can normally do that type of level of detail as well. But then we're converting that data with millimeter accuracy. Here we're showing it in imperial measurements from the US market for head frames and the structures, and actually the ability to model that in a sort of a BIM function almost, design analysis tool, which is the OpenTower designer in this case, which can give you all the metrics for stresses, strains, and there's loads more details there. OpenTower IQ's got a bit coming up in a minute. The ability now to simulate an overlay, really you need the millimeter engineering to identify poles, the size of poles, the kind of brackets, what's free, what's not free with the AI analytics, and then simulate new equipment, as you can see there, and get an immediate capacity change, as you can see. Yeah? As you add those antennas, the capacity ratio gives you a quick reference. Now, that just benefit alone to the sales teams and functionality within organizations to say, yes, we can accommodate you and progress a hosting application or a new technology for your customers or your client. Having that immediate time will show you how that affects the value proposition later. We've used the same graph here because this same function of the design model gives you actually the BIM functionality, where you can see here we've got the antenna identified, the antenna name, the type, the model, and all that identification. And when you look at the OpenTower platform, now I'm going to have to do this carefully because the volume jumps up. So let me just, I suppose we'll stop here and let me just quietly reduce the volume. There we go. As we skip through this, hopefully it won't jump up in volume. You can see at certain points, this just is a video stream of the OpenTower modeling solution. I think the most important bit I wanted to go to, cutting off antennas, showing where they are in position in space, slicing them for a customer so you can actually just show them the bit that they're interested in. I think on here, we've got the spatial awareness with the antennas. Here we are. This is very important here. If I just pause that there for a minute. The analytics capability here is now bringing out all of the cross-referencing to make model part numbers, almost ownership function, and listing it. So it's doing an analytic on this, and it's making a representation. I'd advise you to go and have a look at this in more detail because it's very, very clever. The engineering grade data, the millimeter data, just refines the process. It gets all the shapes and the edges, and it just reduces the number of options you get to pick. As we may know in the telecoms industry, the antennas may have very similar shapes, very similar sizes. So to get an AI recognition of them may not 100% be accurate. So the more definition you have within that image set to get that reference in can reinforce and refocus the number of options that it lists out for make, model. And just make special note, the a kickoff of a project in the US at the moment where we're doing a rip and replace project for looking for specific items of equipment with the AI analytics so that we can identify where they've gone into certain towers and automatically identify them rather than have to just visually identify them. So that's very important as well. And there's lots of companies around the world looking at that type of technology where we move on. And as we scan through this video quickly, we've got the AI recognition here for the equipment, the simulation functions as we just showed you. I won't play the whole video because it's fairly long, but then as it exports to the tower designer model, you get your structural analysis with the extractions of the measurements through to the results and the output reports. We're talking about speeding up the whole process. So that's OpenTower Designer. I want to click on quickly to the end of that. The justification for millimeter data in our minds is the legacy data standards that are out there in the industry. Certain markets better than others, but generally speaking, the lack of as-built drawings up to date and registered, the lack of a structural analysis which is up to date and not just generic, and the asset register are three key component parts which justify the use of millimeter grade data. You can identify the assets on the tower with a Phantom and a lot of processing standard platforms, but you need millimeter grade data to get a drawing and to get a structural analysis if there isn't one to leverage upon or make justification or judgment upon. And so this is our position on why we need to create that good data set where we're lacking. I'm speaking from experience here, having done many due diligence opportunities over the past 10 years for investors, sellers, and purchasers of tower infrastructure, where you may not be shocked to know, but the lack of information available as part of that sale or leaseback or M&A activity is shocking, where they don't have up-to-date drawings or current structural ratio position. And if it's not there, it's not there. What we're trying to do is, it's an expensive activity to go out and 100% fill that gap by using traditional methods. We're trying to develop here. You're going to have to go and see the site anyway, capture it in high-grade quality data, run a few samples, land bank the rest of the information, use it when you need it. And so legacy data is critical to ownership and insurance purposes as part of the network. I'm not going to hang on this one too much, but it's the understanding of 3D data. So inspection class goes down to centimeter range, engineering class is millimeter range. And I've explained in those previous sets there of why it's important, but we've got a few key points. What's critical in an analysis is bolt diameters, diameters of tubes, thicknesses of steel members, which have to be measured in millimeter. They're those critical measurements. If you're coming away from that and you're looking at widths or standard, angle sections, they're coming 10mm separations or whatever that is in imperial. So you could get away with centimetre at that point, but if you need to know the thickness of the member, which could constitute 20 to 40% structural capacity difference, you really need the engineering class data. And happy to have chats about how and why that's important. Greg, we're nearly ready, sir. Before we do that, I just want to show you a very, very quick video clip of the comparative of our VI sensor data versus a standard P4P. Again, I'm going to mute this because it's got a loud pop in the beginning, so I'll just mute that there. And I'll talk over this quickly. It's just a very short clip, bit of promo with the logo. Sorry about that, guys. Yeah. Okay, side-by-side comparison of a tower that was flown on the same day by the same engineer using the same software to deliver a P4P scan and survey and a Max 3D survey, engineering grade and inspection grade on the right. I think it speaks for itself, the level of clarity and detail that you can see when you're close in to these pipes. For example, you can see the sizes of the nuts and the bolts. You can actually do the measurements. You can get the thickness and the crispness of the edges of the pipes, where you can take off the measurements using analytics to get the whole averaging of the dimensioning for those pipes through that process. We just skip on very quickly. Let's go up here. There's yeah, I mean, at the base of a monopole structure, for example, the ability to see the actual nuts and bolts and do a measurement and see that there's no clear threads on this. You can see that the edges of the concrete, you know, even the earth straps and the connection details as part of that process. This video has been posted up before on LinkedIn. If you want to go, you can probably go and find it and see more details. Happy to share the links afterwards. Just click on a little bit. Yeah, we're looking at, you know, true ability to be able to scale and measure off this type of functionality. So I'm going to leave it there.
And I guess this ties, yeah, very well with Greg's demonstration, because actually that's one of the things that Greg will show, that if you don't have that sharpness and that high quality on the 3D mesh, the fidelity on the 3D mesh, the experience is just not the same.
Yeah. So, Greg, while you're, I mean, Alicia, can you change the presenter screen, or do I have to stop sharing first?
I can do that. Don't worry. Let me just.
If you can do that, I'll just, while Greg's getting set up, just explain. So, you know, we tied up using the VI data, which is high fidelity data, a number of months ago, and just was so impressed with this technology. And Greg is a bit of a demon on, you know, managing and working through this. He's going to be live in this workspace, as you can see, with the HoloLens. The whole point of this, see it now, right? Yeah, we can see that, Greg.
Excellent.
This is about the collaborative nature. We're both in different countries. We're streaming live, and the ability to join in one location and do an inspection in a slightly different aspect and fully collaborate. And we know there's remote MSVs and other functions that are done using the sort of the tool where we share screen. But this is an immersive environment. And to be honest, Greg will tell you himself, us looking at it on a 2D screen here does not do it justice. You really need to get a go on one of these things. It is just phenomenal. If you've ever used a VR headset or AR technology on gaming or anything else, you appreciate what we're talking about here. It's totally immersive. And the abilities now Greg's going to show. So what we're going to do is going to work in partnership, and we're going to do a little tour of this site. So we're going to zoom in, Greg, using your little camera tool here. We're going to go down to the sort of the entry to the site there. And Greg's going to just stand up, and there we are. We've now zoomed in. We're in the compound. We've got the ability, and it's a little bit jerky, but it's a lot smoother if you're doing it manually. But these are the limitations of streaming and streaming a stream in the virtual environment on a webinar. So, you know, Greg's looking around, and there is some breakdown, as you can see, at the lower levels, because we're not focused on that. We're really focused on the equipment and the monopole and the structure here. But you've got the ability, and you can clearly see the labeling, and you can see the capacity of the generator, for example. But the whole objective for us today is we, without risk, without duress, without weather conditions affecting us, want to go and do an inspection at the time of our leisure. And so Greg's now controlling this. He's going to go and zoom into where the monopole is, move the little icon. Greg, do you want to maybe just comment in relation to what we're seeing with a little micro model versus where we are in the environment while you move over?
Yeah. I'll just mention this just so everyone knows what's happening here. You're seeing what I'm seeing. I'm seeing a stereo perspective model. So I see like a 3D model in my space. I've got the small model rendered in the context of the large model. So it gives you sort of a context of like where you're at. And I can tell you this, one thing that I found interesting, when you're at small scale, it's hard to notice the difference. The two quality models could look almost the same at small scale. But when you really start to see the difference is when you get in at like real one-to-one human scale. And for me, I feel like I've got this cable literally standing right here in front of my hand. And what's nice about the HoloLens, it's a bit different than a web browser, is the human interaction is just my head. I'm just moving my headset, and then with my hand, I navigate the model. So I don't even need a mouse or a keyboard. I can just send my hand in a certain direction, and then I can start looking at this model from anywhere and be immersed in the mesh model. And I can tell you that when I was in the lower quality scan of this mesh, you lose that whole experience of like being there. Like all of this becomes blended and looks like it's just blurry. But here with this quality scan, you're starting to approximate what it's like to actually be at the asset. And so in terms of like getting close to like a human experience, this is where we're getting towards. And this is new technology, the ability to stream over Wi-Fi, unlimited polygons to a wireless device like the headset here. So I'm not loading this model locally. It's just all streaming over Wi-Fi to this device. So it means I don't need to have a hardcore heavy computer plugged into this thing. I just connect to Wi-Fi, and then this is just a context capture photogrammetry mesh that was loaded into that Tower IQ product.
Yeah.
So yeah, go ahead, Spencer. I'm just navigating up here.
Going to navigate up to the first platform here. Look, I used to be a climber myself. You go through weeks and weeks, if not years, of experience of training with, specialist PPE equipment. By the time you get onto site and you've unloaded the kit and you've set up and you've checked your ropes and you've, signed your risk assessments and, checked each other out, and there has to be 2 of you to climb as a minimum. You're going to be an hour maybe before you actually start up the tower. Here, in literally 4 or 5 minutes, we are off the ground and being able to visualize this monopole and the head frame structure here in almost as good a clarity as our human eyes is what we're looking at here. And as you can clearly see, we're at the first level. We can see, the RIU box or RIH box here. We've got the flow forge flooring. We're looking at the connection details. We can see there's cables draped across the floor and potential trip hazards that we could annotate and demark. We're looking at the backs of the antennas and any issues. I don't know, is it at this level, Greg, there's that rope attachment at the main center point? We found some really interesting stuff by just navigating this. Yeah, I think this
might be around here somewhere. Yeah, you could look at the detail here that you can practically read the text on this thing. To me, that's pretty amazing. And in terms of like the fact that the cabling, the photogrammetry is like getting this full kind of 3D articulation here of the actual cable is just amazing.
Yeah, much more than just looking at this on the screen now. As I say, the immersive experience of having this moving image come past your head and being able to rotate your head to closely inspect some of these cables and
I don't know if it's possible, Greg, but if you could move the laptop so that we can see your head moving, because you've disappeared, and I know that you're walking all over the place.
Can you see me now?
Yeah, we can see you now. That's great. Thank you.
Okay.
Again, I suppose for the purposes of the audience, we are getting to view the structure in total security and safety of our own offices at high definition. And the ability, and we'll show you when we get to the top of the structure, we're looking for potential defects and potentially for connection points or whatever our inspections taking us up the tower for. Here Greg goes up the tower to the very top. I'm very interested in engineering. I want to see these connection details here. This is quite an interesting head frame if you're a structural engineer nerd like myself, where there's some connecting issues with it, but you wouldn't be able to see that. You know, these connection details here, the vertical poles aren't actually connected to the main frame at the base of them. They're just hanging in free space at some point. So you can sort of see that, but you can see Jubilee clips, you can see the bolt clarity, you can see the pole dimensions. There's Greg's chair in the office. And, you know, you just navigate around. So, you know, you have the measure functionality within this, you have the annotation function with this, and you can flick to the real life photos as well in the original photo deck. So you want to just totally navigate around the whole top of this infrastructure. What we identified as part of this, you know, is this damage to this antenna. So I'm the tower owner. I'm now looking at this going, one of my customers has a problem. They have a piece of equipment that's maybe damaged by something's hit it, maybe lightning struck it. We don't actually know. It could have been installed incorrectly, but it's something they need to know about. And so we can see the electrical components within the antenna exposed to the environment. It's going to affect their quality. We want our customers to be happy. So we're going to send this. He's going to demarcate this region as a potential area of concern to allocate to another engineer, focus it in. It crops it from the whole image, shows it as an area of concern, annotate that with what the problem is. Obviously, you can rotate around it. We can then issue that back to our office. We can say, look, problem. The customer can go in and maybe view it themselves on a standard visualization process. This all links back to the OpenTower IQ solution that we showed you earlier about the defect annotations within that. If you've seen that platform, this is just the ability to manage and control that way better. And we can perform our full spectrum analysis now of this structure, highlighting defects, highlighting space, capacity, other issues.
I actually have someone there, Spencer, asking if we can apply measurements. So if you guys can talk a little bit about that.
Yeah, so I think Greg's just popped up on the screen there. You know, he's just done a quick measurement point to point across there. Obviously, when we're getting on large measurements, they're quite easy to do. Doing finite measurements is really an analytic stage, which comes through the engineering modeling. That's the partnership with the OpenTower designer piece. But yeah, generally zooming in, doing your widths, doing your head frame sizes. You know, you could take your dimensions of your cross-section poles there, so you know what bracket you needed. You can do all those measurements within this platform. Greg's probably going to ask some questions in his poll afterwards about some of the improvements that you guys would like to see in the future for this type of technology as well, but I'll let him speak about that post sort of our little run through. And you know, we've got a couple of videos recorded of what Greg's doing here live. You know, Greg and I have done this walkthrough on a couple of occasions. I'm an engineer, Greg's not really visited Telecoms towers, and as soon as that insight came through, he was like going and flying around this as if he was fully conversant with a telecom structure. That's how easy it becomes. You know, the whole opportunity for education purposes, for training purposes, for your engineers in the office as well, looking at this information is boundless. You know, it really gives so many opportunities for the HoloLens product. And as you said, Alicia, it doesn't necessarily need to be the Telecoms tower. It could be any piece of infrastructure. We're just showing this because we had a comparative model.
Sorry, Spencer, I have a couple of other questions that I want to ask you guys. There is one from Peter saying, can it be live streamed from the location to the AR unit? Greg, maybe that might be one for you.
Well, yeah, I mean, what I'm showing now is a photogrammetry capture. So the drone took the photos were processed, and now I'm seeing it, and then I could stream that to someone else with Teams. But then the other, if I understand the question right, the other thing you could do, if I was actually at the physical location, because this HoloLens has streaming, like you're seeing what I'm seeing, I could just live stream exactly what I see back to someone else through a video feed. So you wouldn't be seeing the mesh, you'd be seeing reality. Yeah. And so that's just sort of a default functionality built into the HoloLens, which is just like what you're seeing now. At any point, you can just stream whatever you're seeing to anyone else. So that integrates with Teams or Zooms or Zoom, you know, whatever that is. So yeah, absolutely. A lot of people use the HoloLens just for that. In fact, just to go somewhere, turn on the onboard camera and just show people what you're seeing.
Mm.
I think maybe the question pertains to the AI properties that are
oh, the properties. Oh,
model.
yeah. If we had AI feeds here, absolutely. Oh, good point. Yeah, if there was an like an IoT sensor connected to this piece of equipment right here. I mean, it's not in this demo, but you could have a pop-up feed right here just showing like a graph, a chart. So that's just more like connecting a back end to your IoT, whatever that happens to be.
So there could be, sorry, Greg, because that's actually another question we're getting. So could they build an AI to recognize the equipment, sort of like the make, the model of the different equipments? Would that be possible on the iTwin platform?
Yeah, I believe that's what Spence was showing. So with the OpenTower IQ, that's sort of what it's meant to do. It applies AI detection, and it puts extrusions and shapes on these photogrammetry meshes. So it becomes more than just a mesh. It becomes an object.
Yeah.
Okay.
And that's what it does in the OpenTower IQ. And it is a piece of work in progress that the HoloLens product would mimic exactly what you see on those AI functionality screen. So you would literally do what Greg's doing here and be able to touch the antenna, and a bubble would pop up with all of its key metrics, identification, height, width, dimensions, or azimuth, tilts, rolls, ownership, maybe, make, model, part number, where all that information. And the same with, looking at the conditional factors as well. That linking process is under testing, I think, or at least under planning, to incorporate into this model. So now it's not just used for an inspection, it's used for the full spectrum of what you can achieve with the analytics from scanning.
I got, thanks for that, Spencer. I got actually a good one from James asking, the measurement you took, Greg, was in meters, but because we have millimeter accuracy on the 3D model, is there a way to actually do measurements that are in millimeters rather than meters?
Yeah, you could just tune that. The app is just showing meters, but you could absolutely you could modify the app to show, sorry.
So you could go as little as you want.
Formats.
Basically, you just zoom in, and then you will just be able to do that measurement, for example, of a bolt or something like that. Is it?
Yeah, you'd have to configure the app to show either millimeter or meter. So that's that's just a UX concern, really. Yeah.
Okay. Cool.
Yeah, and there's a lot of what I'm interested in kind of learning from the audience. So what you're seeing is like what we've built is basic. Just to be clear, this is basic model navigation at this point. So like the step one to any model viewing is you have to be able to view it, render it, interact with it. So if you think about a base web app, it's very similar. You have typically you've got zoom, scrolling, flying through the model is sort of like step one. Step two is like measurements, saving views, creating issues, dropping pins, that kind of thing, access to metadata like properties. So that's kind of all in the roadmap. And I'd love to hear from the audience, like, how would you prioritize, like what would be the most important next features you'd imagine in a mixed reality application? And again, thinking that it could work against any asset that can be scanned, whether it's a cell phone tower, an offshore oil rig, a dam, a bridge. We've also had clients looking at doing facade inspections with drones, so tall high rises. I think almost like anything that would become inherently difficult to get to physically as a human, does that drone kind of just alleviate that, that danger situation and the cost associated with getting into, hard to reach places? And then what would you do, assuming you could do it in a HoloLens? Where would you put that $100?
Greg, do you mind actually, because we've getting a couple of questions regarding what's the platform actually that you are using. So will you maybe explain again the iTwin platform very briefly?
Yep, so this is what's behind this. I'll just jump to this slide right here. Let me know if you guys can see this slide. Yeah, so really what we're talking about here is we call it the iTwin platform. And what it is, it's really a convergence of two things, right? What I call 3D, 4D virtual models, right? Three-dimensional models coming from a range of file formats and sources on the one hand, and then digital reality on the other. And digital reality is everything you see in that list. It can be drone capture, LiDAR, point clouds, it can be IoT sensors. So you have this kind of convergence of digital truth and then real truth through digital capture. And they come together what we call infrastructure digital twin. And the platform is engineered, designed to support whatever your imagination can come up with, assuming these are inputs. And then the types of outputs can be really whatever you imagine. So the OpenTower IQ is an example of a web app focused on an input of photogrammetry and engineering models and AI ML into it. And then we extended that experience out to the HoloLens. So that's sort of the platform, and it works with also common game engines like Unreal and Unity. So if you have to kind of go out to beyond the web, then you build apps for Unity and Unreal. So what I just showed you, for example, in the HoloLens, the back end is iTwin. The front end, all those menus and interactions, is actually Unity, just UX controls running in the Unity app running on the HoloLens. And then the back end is the iTwin platform, and that's running on another layer, which is all Azure, Microsoft Azure. So the streaming actually was coming from an Azure remote rendering service, streaming pixels to the HoloLens. So that's kind of in a nutshell the platform, and all the digital twin products on offer from Bentley today are built on top of this platform. And we're also extending the platform so that any development partner like Visual Intelligence or any other ISV in the market, you could actually build your own digital twin solution on top of this technology. So hope that gives you an overview.
Yes, thank you so much for that, Greg. We've got a couple of questions still about the millimeter accuracy. I was just typing in there, but we addressed this topic last week in a live session. I've copied the link to that live session on the chat box. But if you download the handouts, the infographic and the other article or document, they actually explain quite well how the data was acquired and the accuracy and fidelity of the data you are seeing on the screen now. So feel free to check that if you have any more questions about the millimeter resolution and accuracy of the data. If you're done with the demo, Greg, will we launch the poll about the HoloLens? Actually, I think you were asking that question just now, weren't you?
Yeah, I would love to get some feedback on how people would prioritize the features they'd want to put into a mixed reality experience. So yeah, if you can launch that, would be great.
Yeah, so if you guys go back to your GoToWebinar screen, you should be able to see now the question, which of the following features will you consider essential for a mixed reality solution? And you have measurement tools, access to metadata, ability to create and flag issues, connection to IoT data, and multiple users in the same environment. So if you quickly go back to the GoToWebinar and please pick one of the answers, that would be great. I see lots of people answering already. We
did see a question in there too about the UI from the HoloLens. I think we got that answered, right?
Yeah, I think most of them. Let me just go through again quite quickly. And also feel free to drop a comment with any other features that are not listed in here. Okay, so let me close the poll now. We have 60% people voted, and we'll share the results. So there we go. We have ability to create and flag issues, followed by measurement tools, and access to metadata. Oh my gosh. Cool. Thank you so much for that. Let me just hide the results. That's interesting, isn't it? Like measurement tools and ability to create and flag issues. That's you were demoing that, so I guess that's already in there. So how about the multiple users in the same environment, for example? I know you guys are working on that, or How that?
Yeah, it's a prototype we built. That's why I was wanting to ask about that. We do have the ability, but it's not in the demo I just showed to bring people. So not just stream what I'm seeing, but actually if you have multiple people with a HoloLens in different locations, we can all log into a shared session. We would each see a version of that tower in our local environment, but then we would see avatars of the other people in our space too. So it allows you to communicate and talk about that hologram from like remote. It's like remote collaboration with holograms. So it's what people are now calling the metaverse is one phrase for it, but it's really possible. If there are people interested in exploring that space, I'd love to connect with them and maybe run some prototyping. But yeah, the other feature is not surprising. I think measurement's huge, adding issues huge. I think you need those pieces first before you get to multi-user.
Oh,
So I think
100%.
that makes sense.
I repeat that as well. Once this becomes the traditional norm of how we do inspections and how we gather data, you will see a transcending from, you know, the measurement and the ability to flag, because it will be the norm, to how we now use that data, how we synchronize that with other business cases, how we connect to the IoT data streams. At the moment, that's the two most important things from any owner or any engineering company that they're going to want to use this technology for, the ability to do those basic things of what we've represented and what we've showed, Greg, which is why we focused on that. So not unsurprising. I presume, you know, the collaborative thing in the same environment, 12%, you would have expected a bit more. I think if people used it, that number would jump up because it is truly fantastic. So yeah, that's my comments on that.
Excellent.
Good demo though.
Great demo.
Yeah,
Thank you.
I'm constantly fascinated by it. Yeah, the more, by the way, it works with any photogram. That's what's so cool about this. If you go to that level of detail, like visual intelligence is providing, it's amazing. I've seen like very low res captures from drones. You pop that into the HoloLens, it just kind of loses the effect. It might look cool in a browser, you know, staring at 100 meters away from it. But this ability to kind of get right up to it makes a huge difference. I've seen similar examples for bridges where like literally you can stand arm's length away and you feel like you're seeing the bridge, the bolt connections, the detail, the rust. And so I think there's a huge value in that kind of quality of capture. I think honestly, this becomes the evolution of photography, right?
Yeah.
Behind all this, it is high-res photos, right? That's it's a lot of high-res photos, but then now they're kind of merging together with photogrammetry into this new way of interacting with photos. Like I think it's just the new medium of photo interaction. So I think it's a super cool evolution of the tech and very practical. I think, you know, it's because it connects with you at a human scale, right? Like Spencer, like you feel like you're at the thing in real scale. Like when you wear it, it seems like this tower's like literally in this room with me.
Yeah, which is very important for the experience, you know. It's a high risk activity, you know. I've worked in that, climbed the towers, you know, you climb in all sorts of weather conditions, and it's, as I explained before, quite a long time to get set up before you go into it, quite expensive to do that as well. But just the risk and I suppose the number of people required to do this type of, you know, inspection grade and routine inspections in a growing telecoms environment, limited resources, and it just gives you that total different dynamic. And again, I can't recommend it enough, really. It's totally immersive.
Cool. Thank you so much for the demo.
Were there any more questions, or is that, no problem, absolutely.
We have another couple of questions. I'm not sure we have the time to address them all, but we had one regarding the HoloLens. So does this work with the first generation of HoloLens?
No, this is all HoloLens 2. Yeah, everything you saw. That's an interesting question. One thing I'll point out, something that's really, I think, been amazing working with this one, V2. One, you can see it. I do have the flip up headset here. Two, everything works with just natural hand interactions, which you did not have that in HoloLens 1. So all those menus, I'm just grabbing and moving with my hands. It's very intuitive, and also the field of view got bigger by 2x.
And there was another one about the resolution. Sorry, Spencer, before we move on back to you, which I thought it was interesting. The resolution you get on the HoloLens, is it the same as on the computer screen? So I guess it's, does it downsample at any stage the 3D mesh to load on the 3D on the HoloLens?
A really good question. Actually, there's no downsampling about this. In fact, it's full resolution streaming at 60 frames a second. And I can't remember the name of it, but it's not a pixel definition with the HoloLens. It's this is using, it's basically reflecting light back into your retina, and it's more like a degree, like amount of like light per radian or something like that. But what I can tell you is you never see a pixel, if that makes sense with this. So you see full high res, you don't see like an aliasing, and it's at 60 frames a second. So I think it's amazing. Even in a web browser, you sort of have to deal with multi-resolution kind of tiling, like at a certain zoom scale, the model kind of refines. With this Azure remote streaming, it's full res the whole time.
Thank you for that.
Yep.
Cool. Spencer, do you want to move on to your, we have 5 minutes left, unless everyone, I've seen a few people dropping already, but we should think about wrapping it up.
You can see my screen okay, yeah?
Yes.
Yeah, perfect. So to close up for the audience, what we wanted to really touch upon is, well, now you've seen how it's collected, what we're doing, how we're demonstrating it, how we're purposing that data. Where does it make a difference downstream? And again, we're talking from a position of inspection grade to engineering grade. Where does the difference come into this? So the areas that we've focused and done value checks and propositions on are looking at the information sharing, the total cost of ownership, truck rolls, maintenance, engineering, functionality, leasing, mergers, acquisition. If you remember the blue chart that we did with the gradients on it, these are a couple of the use case value propositions where we've come from. So very, very quickly, we are looking at information sharing across a business being total cost of managing that data across a business 70% less, because we're now viewing and able to view in a totally different environment across business sets between sales teams, health and safety teams, engineering teams, ops and maintenance teams, regulatory, all of these functions, being able to get this view that they could never see before. We're not just looking at a drawing that not everybody understands. People understand this immersive intervention, but it's the engineering level that makes a difference. From a total cost of ownership of a site, we're showing over, say, a 10-year lifespan of a typical telecoms tower, where once every couple of years it's touched in some sort of technology upgrade or tenancy pro rata increase or engineering adjustment, that you're showing 42% savings by having this engineering grade data and reusing, recycling and re-engineering that data without having to go back truck roll, go back to measure the member now that it failed. You've land banked that data, you know what size the bolt is, I know what bracket to take with me, all of those current functions. With relation to leasing, how would you like to be able to save like a traditional, what we're saying here, 46 days from an inquiry to maybe on-air readiness for an operator or a technology upgrade down to 2 days, because you had all that information available. And again, the massive reduction in cost that time period has to go with it as well. And again, we can share some of this detail with you. M&A activity, now, having worked in this myself, looking at doing these transactions 33% quicker, doing a due diligence 33% quicker because of the time it takes to manage and acquire this data and process the data. A 40% reduction in transaction costs of gathering the data, and then now you have all that data land bank, so the operational efficiency moving forward. I do this quite regularly, and it's true how that works, and I'd love to share more detail. And then ultimately engineering. I mean, a 50% realistic saving, probably more, in traditional how we did it yesterday of climbers and measurement and the error conversion rates and all of that to the drone application process, deliver the engineering model. We're being very lenient with 50% of the time, but ultimately all of those things, which we're happy to justify and go through in more detail with any of the audience, ultimately arrive at giving that sort of engineering grade solution a tick next to all of these downstream values. The savings enterprise value alone are in the billions for a carrier or a big tower owner. And we're happy to go through those details with you. So won't dwell on that too much. The combination of that engineering grade data with a tool like HoloLens in an immersive environment with all the engineering data and ability to manage moving forward speeds up, reduces risk, reduces cost, and ultimately, you know, gives the product, which I think is going to be the future. That's pretty much it. We've answered some questions. I'm going to hand back to Alicia. Say thank you to Greg as well as Alicia, and you for listening. Unless there's any more questions, Alicia, I'll turn it over to you.
There is a few questions if you guys have a few more minutes. Yeah.
Yeah.
Okay.
Perfect.
Let's do that. We actually had quite an interesting. Let me go back to that one. So Alex was saying, impressive system. My question is for a known tower and initial structural capability for structural analysis. Spencer, this one is for you. We will need a tower leg wall thickness or monopole shaft thickness and steel grade. That is usually measured using an ultrasonic gauge and confirmed bolts grade via visual inspection and steel grade tester. I'm saying loads of words, but I have no idea what they mean. So how do you address this? The video example with OpenTube is not representative of actual UK market where sections are closed for water egress. Many thanks.
Yeah, look, as a structural engineer, yes, I take all those points validly. You do need to know the steel grade to do a correct analysis. You do need to know the grade of the bolts. You do need to know the wall thickness of a pipe. There are lots of factors that need to be taken into account. But what we're doing is we've built a massive library of traditional standard towers and traditional standard products like we have with the antennas. And we're using that AI analysis to read from standard sections, from standard grades and standard provisions to make those engineering judgments and leverage upon certain legacy data to make those judgments. But you're right, there is always the gap in the process where we've never seen this tower before. We don't have a data point for it. We may still need to do it. But we're reducing that 100% requirement down to a much smaller percentage. Let's use an 80-20 rule to be fair. 80% of everything we see, we're going to be able to associate and assess against product catalogs, against standardized steel grades and steel sections for those known dimensions, because they're in a library, you know, and that's, I suppose, where the OpenTower and the MS Tower flow through all comes through for that. We make assumptions, but the engineering teams in a structural engineering team make assumptions as well. They have to make those assumptions based on certain measurements or mismeasurements or other engineering perspectives or the legacy data that's presented to us. So is it perfect? No, we're not saying it is. Is it an aid to get better? 100%, because that's all we can achieve and move forward. And as the database builds, the ML increases and the more automation comes in line to give you ultimate confidence that we're actually picking the right product and right tools. So totally appreciate the question because it is valid, and yes, there's that gap in the process and there always will be, but we're talking about volume and we're talking about scale and the ability to assess these things en masse. So happy to have a further discussion though, because I know it's very valid.
Thank you so much for that answer, Spencer. There is a few other questions about cost and price, which I'm not going to address now, so I'll follow up on an email. We'll get you in touch with the right people. There is one, Greg, that actually for both of you, and I think with this we can close the webinar. But someone is saying, I see the value in the model and the metrics within, but honestly, I'm having trouble quantifying the value that the HoloLens is bringing. Could you please elaborate? So if you want to maybe close with this one, because I thought it was.
Yeah. I mean, for me, I think you just have to try. It's the visual interaction. It's the one-to-one real scale feeling, and that's impossible to replicate just in a browser. I think you could do most things in a browser for sure, but your mind is still doing a translation between what you see on a screen and then what's in your mind. And so when you're in a one-to-one scale, whether it's a VR experience or in this case, a mixed reality experience, you're seeing the object in its natural form factor at a real scale. So there's no kind of translation necessary for the human. You intrinsically get it it's very intuitive. So I think that as a visual medium, it's the most natural way to interact with digital content is my answer to that. And I think it's only going to evolve. I think we're going to become used to the idea that we just work with holograms, just like we've gotten used to carrying phones around and looking at 3D models on a screen. In the not so distant future, we'll all be used to just seeing, holograms, like what the 6G community maybe refers to as like hi-fi holographic society.
Mm. To add to what Greg's saying, and using this in anger, and I know many of you out there listening will have used platforms, not necessarily, the Bentley one or, others. The frustration of when you zoom in and you zoom past the object and you zoom out and it massively zooms out, and then you're trying to get the right angle and you've got to go from pan to orbit and orbit to pan. That frustration just disappears when you use this tool. I mean, it's so, as Greg was saying, it's so natural to use. You literally feel like you're there and you just move your hands and then you get to the right position. Again, it is an experience that you'll justify it. Yes, there's a cost associated to it. The collaborative measures where you're all in one space looking at this as well are another huge benefit, because I've been on remote MSVs where 6 different people are logging into the same system, but nobody's looking at the same thing. They're all this side of the tower or that side of the tower, and down the bottom, oh, I haven't got up there yet. It's almost like they're disjointed. So that whole collaborative nature of this, give Greg a call and get him to give you a demo. It's
is the one single source of truth that with, like we see with the digital twins. I think that is the actual digital twin, and the collaboration, I think, is one of the key elements, as you said, Spencer. Thank you so much. We already got really good feedback from some attendees, so thanks so much to both of you. I know you are on a holiday, Greg, so that's an extra thank you for being here today, and thank you so much, Spencer, to you and the entire team of Visual Intelligence. It's been amazing to have you guys sharing your experience and your technology and your everything. So thank you so much to both of you, and thanks everyone for joining.
Yeah,
thanks, Alicia. Thanks, Spencer. Thanks, everybody.
Cool.
Bye.
Look after yourselves. Bye. Bye. Bye.
Bye now.
Cheers.
Cheers.